My name is Key, and this is a brief overview of wetland valuation. There are different types of wetlands, and among a few are mudflats, marshes, soft marshes, swamps, and peat bogs. However, each different type of wetland share three common qualities: their individual hydrology, hydrophyte vegetation, and hydric soils. Hydrology, as defined by the United States Geological Survey, is a science that incorporates the occurrence, dissemination, movement, and properties of the waters of the earth and the relationship with the environment within each phase of the hydraulic cycle. Hydrophyte vegetation are plants growing in water or soil that is at least periodically deficient in oxygen due to excessive water content. Hydric soils are soils formed under conditions of saturation, flooding, or punning long enough during the growing season to develop anaerobic conditions in the upper part of the soil. I have annotated 6 different wetland values. Number 1, flood damage control. The slowing of excess water that flows over wetlands is partially absorbed. This reduces flood damage to neighboring environments. Number 2, water supply and groundwater recharge. Even in arid regions, wetlands often play a vital role as a reliable water source. Water flows from wetlands into neighboring ecosystems, which recharges their water table. Number 3, water purification. Coupled with flood damage control, wetlands act as a filter of toxins and sediments from floodwaters. Number 4, recreation. Recreational opportunities to include hunting, fishing, canoeing, and hiking can take place in wetlands, as well as education and research. Number 5, fish and wildlife habitat. Wetlands provide critical habitats for fish and crustaceans that use the waters for breeding. Waterfowl also utilize wetlands for breeding, as well as a rest location during long migrations. Number 6, biodiversity. Wetlands are the most varied ecosystems on the planet Earth. Recreation is a direct use benefit. Water supply, groundwater recharge, flood damage control, and water purification are indirect use benefits. Fish and wildlife habitats, as well as biodiversity, are existence benefits. Wetland valuation related to conservation biology. Conservation biology has 2 goals. Number 1, to evaluate the impact that the human race has on biodiversity, which is a non-use value and/or benefit. Number 2, to create techniques to prevent the eradication of organic creatures. No matter the ecosystem, direct use and existence benefits go hand in hand with conservation biology. Methods of evaluation. Ecosystem management decisions are often based on economic evaluations that rely on attributes that are quantifiable. This quantitative data ensures valid estimates, which assures numbers emphasize the significance of wetlands, which ultimately attribute to policy and management decisions. Trying to tie numbers to valuation is often difficult. For example, the banana prong species located in northern Australia are a part of the most significant fisheries of Australia's coast. The banana prong depends on northern Australia's coastal wetlands for procreation. To estimate the value of Australia's coastal wetlands and their importance in supporting nursery ground food webs, there was a recording of the banana prong's numerical and biomass density. Conducting the sampling occurred during 2015 and 2016's wet season, which historically was a period of high banana prong juvenile abundance, particularly in the Alligator Creek estuary. Unfortunately, there was high spatial and temporal variability. Expectation of a high space and time variability is typical of mobile creatures. As a result, this variability in the data collected produced unreliable results. In reality, we cannot accurately place a monetary value on ecosystem services. This is because of nature's uncertainties. Uncertainty. Uncertainty arises in the benefits of wetlands when posing questions between the association of wetlands and infectious diseases, such as malaria. The 2 factors of concern that will ultimately increase infectious disease probability are: number 1, water development projects that expand the number of wetlands. Number 2, changing of the seasonality of the wetland due to water regulation. For example, Damming of a water source stops and backs up water flow and will eventually pool and stagnate in a catchment area. However, I cannot find any recorded case studies that support or dismiss the association of wetlands and infectious diseases. Every wetland variation has a particular value or benefit. Although placing an actual statistical proven monetary value on wetlands is difficult, the effects of their value are felt throughout environmental economics.